firstly we will create a random forest model, and then we will plot all the graphs related to that random forest model. Create underscore model is used to create a model. And what is the short form of random forest model? RF is the short form. So RF model is created right here. Execute this. You will see this model is created with all the parameters. Okay. Now, what we will do after creating this particular model, we have to plot the RF model's errors, okay, which are present. So how you will plot this? You have to use RF underscore model, and inside that RF underscore model, you have to define the model name. So what is the model name? Model name is RF, okay. And inside the function you have to use the plot function, okay. So plot is equal to give the keyword of the particular graph, okay. So right here I am using the keyword error, okay. So that means we have to plot this error curve, okay, for this new RF model, okay. So I will execute this line of code and you will see the output, okay. So what is the best fit, what is the identity, what is the R square value, they are represented right here, okay. Okay, so we are just using the same code, but we are replacing right here plot value, okay. So instead of errors we have to change this value to the learning, okay. So right here the keyword learning, okay. So with the help of this learning keyword you can plot the graph for the given model, how it will learn the outputs, okay. So perform this operation right now, and you will see the output of the learning curve. So learning curve will be represented in training instances and the score of its learning, okay. So you have some cross validation score, and you have some training score for the random forest model. So you will see these two curves will be shown inside this particular learning curve, okay. So it will take some time to process the data because it has to plot the learning as well as the training scores, okay, and the validation score. So you will see right here these green dots which are represented right here, they are cross validation score. So what is validation score? I have told you that in in the time of testing, okay, in the time of testing you have to give unseen data to the model, and that unseen data is to be correctly predicted, okay. So the correctly predicted values are shown like this, okay. So what is the score of your model right here? Up to 82%, it will give you the accuracy, okay. But in case of training score you will see your accuracy is 100%, okay. 95 to 98 and 99% accuracy you are achieving with the help of this training data. But in case of testing you are getting up to 82 or 83% accuracy, okay. So you will see this is the training instance, that is how much training data you are providing. So 100 samples are there, 150 sample, 200 sample, 250 sample, 300 sample, and up to 350 samples you will provide to this particular random forest model for the the given data, and it will give you the accuracy like this. Learning, we are replacing it by VC. VC is the keyword for validation curve, okay. So you will execute this line of code, and you will see the graph in between the cross validation score and the training score of actual estimated maximum depth of that value and the score of the given data set, okay. So It will take few minutes to process this training as well as validation process, and it will plot all the data points between actual estimators and the scores. Okay, right here. Okay, so what is the output it is showing? It is showing in green color. These dots represent the cross validation score. So cross validation is applied at the validation stage where we are providing unseen data to the model, and your data is predicting the output right here. So how much accuracy you are achieving? Somewhat 82% accuracy you are achieving right here. Okay, and in the training phase it start from 60%, and it will goes up to 98%. Okay, so training, as you can see, training accuracy is higher as compared to the testing accuracy. So you need to apply some parameters, okay, to this particular data set and model, and you will improve this accuracy. So using create underscore model, you will use the keyword rf. Rf stand for random forest model, and we will set was equal to true, so it will not give you runtime output. And here you you will see verbose is false. When you put this verbose equal to true, it will show you the runtime output. If you will put this verbose equal to false, it will not give you the runtime output. Okay, so verbose, that's I'm explaining. You initially I have set it false. That means it will not show you the runtime output. You will change it to the true. Okay, you will see the runtime output. Okay, after that we are plotting this model with the help of this RF model, and we assign the keyword as a feature. Okay, so it will show you the important features of your model. Okay, so initially I have set this was equal to false. That means you can see right here it is not showing the output. It will directly show the final output. Okay, so if I will use this verbose equal to true, okay, if I will use this verbose equal to true, then you will execute it. You will see the runtime output is appearing right here. Okay, runtime output is appearing right here, and after this runtime output you will get the final output. Okay, so to remove the runtime output, we have set this verbose equal to false. So here you can see these two are the important features for this particular random forest. Okay, RM and instant. Okay, and after this we will use the feature importance for extra tree regression. So how you will use the extra tree regression? I have given you the short form of extra tree regression as ET, and just replace this random forest RF with ET. Okay, and plot the important features of this particular model. Okay, so after performing this, you will see the output, which column is showing the maximum value. This RM and instant uh, stat is showing the highest variable importance. So right here you can also observe, and third one is your decision tree. So what is the name of this variable which we are defining for decision tree? We are using dt. Yes, replace this et with dt, and we will execute this line of code, and you will find similar outputs right here, but instant stat is somewhat lower importance, but rm is the maximum importance for this particular variable. Okay,